Okay, so let's calculate this derivative the formal way using limits. Let's be good and precise about it. My function is going to be f of x equals the square root of x. And if I'm going to calculate its derivative, I need to use my limit formula. So f prime of x is equal to the limit as h goes to 0. And my difference quotient, as always, is f of x plus h minus f of x, quantity divided by h. Now, when I see f of anything, I'm going to take whatever I see between those parentheses, and I'm going to replace it in my formula. So f of x plus h becomes square root of x plus h. F of x becomes square root of x. As I take the limit as h goes to 0, well, both that numerator and that denominator are going to 0, and 0 over 0 is indeterminate. I can't assign a number to that expression. It's a bit of a problem. So my standard trick for dealing with adding or subtracting square roots is to say I'm going to take those very same square roots and I'm going to flip the sign. They are combined by a minus sign here, so I will combine them by a plus sign to the right. Now, I don't want to change the value of my fraction. I need this to actually be the same numerical answer as the thing I started with. So I need to multiply on the numerator and the denominator of the fraction. The cool thing is that when I do this and when I FOIL out my numerator, I will get cancellation every single time. So my outer two terms are two different square roots multiplied together. They're both positive. My inner two terms are those same square roots again, but now one of them is negative. So that's where I get my cancellation. I've skipped some steps in the algebra to get to my next line here. I get a numerator of x plus h minus x. This is all on the denominator, h times quantity x plus, square root of x plus h, which is then added to the square root of x. Now, x minus x I know is 0, and if I have a numerator of just h and an h on my denominator, those will cancel. Remember, those cancel because my h here is a factor of the denominator. I have factored it out of every single term there. So now I'm taking the limit of 1 divided by square root of x plus h quantity plus square root of x. Well, h is going to 0, so that must be 1 divided by the square root of x plus the square root of x. Well, hey, that's what I would call 1 divided by twice the square root of x, which is what I got for my intuitive answer as well. So this formal definition gets me the answer that I would expect from my previous intuitive approach.